Hello friends, today we'll be discussing LeetCode problem of the day, that is 1443, minimum time to collect all apples in a tree. Okay, so this is the third consecutive question on tree that LeetCode has given as a problem of day. So let's understand the problem statement. And well, the problem is a mediocre problem. So this is a medium problem. So it said that you are given an undirected tree. So pointer is undirected tree. Okay, and it consisting of n vertices, and the vertices are numbered from 0 to n minus 1. This is the first observation, and it is also said that some of the vertices have apples in them. You spend 1 second to walk over one edge to the tree. Return the minimum time in seconds you need to spend to collect all the apples in the tree, starting at the vertex 0 and coming back to the vertex. It is it's saying that some of this n vertices have apple, right? And what we have to do, we have to return minimum time to collect all apples from, sorry, it should be starting from 0 index and reaching back to 0th index. I guess the problem statement is pretty clear to you. We are given an undirected tree that consists of n vertices. Each vertice is numbered from 0 to -1. Some of these vertices have apples. Our task is to return the minimum time we are required to collect all these apples while starting from the 0th index or the 0th node and returning back to the 0th node. And one more thing I forgot to mention is that time taken to visit not visit to travel a edge is once. So it's pretty clear, the statement is pretty forward. If there is a edge between this 1 and 2, from going to this it will take 1 second and coming back it will take 1 second. So the round trip will be of 2 seconds. The trip will be of 2 seconds. So this is the idea the problem is trying to convey. So let's quickly move to the approach of this problem. So let's start with the approach, the thinking or the intuition of this problem. Let's take a tree. I have taken a tree A. This is our tree. So can you guys tell me what will be the maximum time? What will be the time to travel all the nodes? Yeah. So let's calculate this. From 0 we will start. From 0 we will go to 1. It will take 1. From 1 to we will go to 3. It will take 1. From then 3 to we will come back to 1. It will take 1 more second. From 1 we will go to 4. It will take 1. From 4 1 to from 4 to 1 we will go, then we will take 1. Similarly from here, then here we will go, then we will come back, then here we will go, then we will come back. So if we count, the total time will be taken as all this arrows I will count: 1 2 3 4 5 6 7 8 9 10 11 12. So time is coming out to be 12. So if I say that if all the if you take a special case, if all node have a apple, we can say total time or the minimum time. Will be equal to time required to travel all nodes. So like this is the basic thing you can deduce from this thing. So if you carefully look at the time, right, let's look at the time. So look at, like, for traveling this in this particular tree, for traveling all the nodes, we got the time to be t equals to 12 seconds. So can you deduce some in like some observation from this thing? There's a very important observation like that will be needed to solve this question. Can we say total time equals to 2 times this is the observation that I was talking about. So like total time to traverse all nodes will be equal to twice the number of edges. Like if you count the number of edges in this particular tree, it will be 1 2 3 4 5 6. So there are 6 edges, therefore the total time required to travel all the node ones will be 12. So like okay, so this is like the concept that I need you guys to know. So one more thing we can say from this point is, like, we can say, like, the question is asking us to return the minimum time to collect all the apples. So we can say 2 cross number of edges will be the max time. Got it? This will be the max time that you will be required to collect all the apples. Now what I'm thinking is, like, we will cut those node which doesn't have any apple. So let's understand this with a example. You will like get it more clearly. Taking this like sample tree to understand our concept of solving this question. So let me ask some like basic question. So what are the number of nodes you are seeing in this tree? So I guess there are 10 nodes because we are starting from 0 index and the maximum number is 9. That's why there are 10 nodes. What is the number of edges? Number of edges is equal to number of node minus 1. That will be 9 edges. And what will be the max time to travel the tree? That will be 18. Got it? So these are the key observations that you have to make while looking at this tree. Okay. So answer me one thing. Is it necessary to travel this particular subtree? It is necessary to count the time that we require to travel this subtree. Yeah, we don't need to travel this subtree because neither this node, neither this node, neither this node, they doesn't, like, the whole subtree doesn't have any apple. So what we can do, we can just go to 2, we can collect the apple, and we can decide, like, okay, I will not go to 7 because this subtree doesn't have any apples. So we will not count this time in our traversing time. So what we can do, we can simply do max time, that is 2 into edges minus time for traveling this sub tree. Got it? So we can subtract the time required for traveling this subtree from the max time. So this will like take you to the optimal or the minimum time required to collect all the apples, right? Similarly, we can say same thing for this subtree also. This doesn't have any apples. We don't need to travel this tree subtree. Sorry. Similarly for this subtree, okay. And if you look, one also doesn't have like this subtree. For this subtree, while the root node doesn't have any apple, root node doesn't have an apple, but the child are having apple, so it is necessary to travel this subtree. So there is the logic. If the subtree doesn't have any apple, don't travel that particular subtree. Subtract the time you need to travel that subtree from the maximum time. So this is like the main thing you need to solve this problem. And okay, now let's move to how to calculate time you require to travel this particular subtree. Let's say this particular example only. 2 7 8 9. I'm just expanded that subtree. 2 has the apple, so that's why I'm making it red. So can you tell me what is the time required to travel this particular tree? Yeah. You have to like just count the number of edges. There are 2 edges, so the time required to be 2 into 4. Sorry, really sorry, into 2 equal to 4, so that will be time. No, but you forgot to add the time that you require to reach the node 7. So I guess the time required to node 7 is 1 second, and coming back from node 7 will be 1 second, so that will be total time will be 6. So total time required to travel this particular subtree is 6. So we can subtract this time from the max time. So this will be this thing will give us like take closest to our minimum answer. So what we can do, we can create a function that will check that is this it is like, is it necessary to visit this subtree, and if it necessary to visit subtree, just include the time required to visit subtree, else subtract that time from the maximum time. So like you might like this will sound overwhelming to you. No worry, I will just explain the solution like here only, the submitted solution that the LeetCode accepted it. Okay, so here is what, like, just start understanding it. What I've done, I've just created a variable maxStep that will be equal to the number of like that will be the max time required to travel the tree, and that will be equal to 2 times the edges, and we know like edge equals to n minus 1, so that's why I've written like 2 into n minus 1. Then I'm creating a map, and using this another map I'm creating the tree, because we have provided this area vector of edges. We are like just mapping creating a tree from it using those edges. Then I've created a function solve, and this is the main heart and soul of this whole problem. This solve function do some magic, and it will tell us the minimum time required to travel the tree. So like what I'm doing in the solve function, I'm taking the reference pointer to the max step, the map, the hasApple like boolean, where like boolean vector, then the node and the parent. The parent basically means the node, like the from which like the node has generated, or the node which has called this particular node, the parent basically, because we are using this variable because else like we will, this as the tree is like undirected, if we travel back to the parent and then back to child, so this will cause a like time error, or you can say it will cause an infinite thing, so it will give you a TLE. So we have to keep check that we doesn't we like what I can say, we don't travel to parent from child. So this is like for keeping that check, we have to only travel from parent to child, not from child to parent. Yeah, so then what I'm doing is I made a mess here, let me clear it. Okay, then I'm saying that we will initialize a variable into visit node, like I by basically use int here and here. You can like just replace with the bool, but int will also work fine, no issues. So I've initialize the variable to visit node to be false. Initially we are saying that we don't need to visit this node, but after some calculation we will check like okay, do we need to update our answer or not. So what I'm doing, I'm calling this solve function for each and every child of this node except the parent. Like you can see, I've written a continuous statement if the current child is equal to parent to avoid TLEs and all. Then I'm calling this to like this solve function for this all the child, and have updated the parent and the child in this particular node. And this function will return us, this solve function will return us the to visit node as or not. So this function is a boolean variable, so it will return us okay to visit the node or not. It will return us true or false value. So let's say you have a tree this kind of structure. Let me use some other color. This is 2, this is 1, this is 3, this is 4, and this is, so you can see like the 5 has, and this is like we are this is 0th node, so we have to be, so you can see like this 5 as a apple, this 5 as a apple, so it will make necessary to visit 2. So that what I'm trying to say, to visit node will, it will make it necessary, it will like it will be necessary to visit 2. So that while like all the child doesn't have any apple, only one child has the apple, so it will make it like necessary to visit the 2. So what I'm taking what I'm doing, I'm like calling it for this function for every child. I'm taking the answer and I'm just taking the like the OR operation. So what the OR operation will do is like OR of like n values, and if any of the value is true, it will give the true output. So that what like the function we need. If any of the child has an apple, it is necessary to like visit that particular node. If any of this subtrees are having that apple, it is necessary to visit that particular node. Yeah, you got the concept. Yeah. So then what I am doing, so I'm just taking OR operation. Like it is basically check like if the current node has an apple or the children has an apple, then return true. Okay, if the current node has the apple or the children have any apple, just return true. And if the if this above condition doesn't follow, like for this particular node one, but both condition will not follow this, like to visit node, like it is child, like there are no child, but its child doesn't have any apples, and this particular current node also doesn't have anything. So what we can say, we can just decrease -2 from the total step. So we can just remove this node, and the step that was required to travel this node was 2. Yeah, because from 2 we will go to 1 and 1 will go to 2. So that was the like step required to travel to that particular node. So we can decrease this thing from the total answer. This is like the magic that function is doing, and we will return false. So like you might have got the gist of this function. So this is a basic DFS function with some modifications. Like we are just checking that it is like if the node or the child have any apple, just visit that particular node. If the node doesn't have any apple or the child doesn't have any apple, just remove that particular node from step required to remove from that like just remove that steps like -2 the maximum step. So this will like give us the total answer. And at last what I'm doing, I'm just getting the boolean. So like this thing will tell us to visit trees to like it is feasible, like if the tree doesn't have any apple. You can see the test case like the example 3 in the sorry the example 3, the node doesn't like any of the node doesn't have any apple, so it is not necessary to visit the tree only. So this boolean will give you that true or false, and if it is true, just return the maximum step. This function will have modified it because we are passing a reference to this particular, like we are using ampersand here. So this will be modified, maximum step will be modified to minimum step. Just return the maximum step, and else return 0. So I guess this thing was like clear to you. Yeah. This is what like crazy thing happening here. This like was a very good question. You have to just brainstorm it like little bit, that the main concept was there. Just you have to think like the number of nodes you are required to visit, and you have to just greedily choose that subtree that you need to visit and the subtree that you don't need to visit. So I guess this was my solution for this problem, my approach basically. I thought of it. While this approach is a bit like incompetent, like you can say a bit time inconsistent, because I just got like 70% beat while the official LeetCode solution was giving 80%. So I'm just checking why my solution is like lagging behind. This was like this is for the LeetCode official, and this was around 70% beat. So I'm just checking like what optimization we can do in this particular, because just like I'm happy this that I implemented this solution on myself. Like you guys have any doubts, just comment below. I will try to like my best to explain your like answer your queries. And like okay, then bye, meet you tomorrow with the new problem ready. Have a good day. Bye.